Hello everyone, and welcome to our lesson on number and sum of divisors in number theory. I'm Kazel and I'll be joined by Raynan and Jonathan. Together, we'll explore the fascinating properties of divisors. Let's get started. In today's lesson, we'll cover four key topics: the concept of divisors, how to calculate the number of divisors, how to compute the sum of divisors, and applications and examples to solidify your understanding.
Let's begin by defining divisors. A divisor of a number is an integer that divides exactly, leaving no remainder. For example, the divisors of 6 are 1, 2, 3, and 6 because these numbers divide 6 evenly. Now let's learn how to calculate the number of divisors of a number. So for step 1, write as it prime factorization. For example, let n is equal to 12. Its prime factorization is 12 is equal to 2 raised to 2 and 3. This means 12 is the product of 2 raised to the power of 2 and 3 raised to the power of 1. So for step 2, by using the formula d of n is equal to the product of e sub 1 plus 1, e sub 2 plus 1, and so on for all prime factors of n. So for step 3, by applying the formula 4, 12 is equal to 2 raised to 2 and 3, we calculate it d of 12 is equal to 2 plus 1 times 1 plus 1 is equal to 3 times 2 is equal to 6. So therefore, 12 has 6 divisors, which is 1, 2, 3, 4, 6, and 12. Now let's solve a practice question together. Find the number of divisors of n is equal to 30. For step 1, prime factorize n is equal to 30 is equal to 2 times 3 times 5. So for step 2, by using the formula d of n is equal to e sub 1 plus 1 times e sub 2 plus 1 times e sub 3 plus 1. So for step 3, substitute the values. So it means d of 30 is equal to 1 plus 1 times 1 plus 1 times 1 plus 1. So it is equal to 2 times 2 times 2 is equal to 8. So therefore, 30 has 8 divisors, which is 1, 2, 3, 5, 6, 10, 15, and 30.
Next, let's talk about the sum of divisors denoted as sigma of n. This represents the sum of all positive divisors of n. For example, if n is equals to 6, its divisor are 1, 2, 3, and 6. The sum of all of these, we use the formula sigma of 6 is equal to 1 plus 2 plus 3 plus 6 is equals to 12. To calculate the sum of divisors, we use this formula. Sigma of n equals the product of I equals to 1 to k of the fraction p sub I raised to the power of e sub I plus 1 minus 1 all over p sub 1 minus 1. For example, let's find the sigma of 12. 12 is equal to 2 to the power of 2 times 3 to the power of 1. Step 2, apply the formula. Sigma of 12 equals the quantity of 2 to the power of 2 plus 1 minus 1 all over 2 minus 1 times the quantity of 3 to the power of 1 plus 1 over 3 minus 1. Then step 3, let's simplify. Sigma of 12 equals to the quantity of 8 minus 1 divided by 1 over 1 times the quantity of 9 minus 1 over 2 is equal to 7 times 4 equals to 8. So the sum of the divisors of 12 is 28. Here's a practice question. Find sigma of 30. Again, step 1, factorize n30 is equal to 2 to the power of 1, 3 to the power of 1, 5 to the power of 1. Step 2, use the formula. Sigma of 30 is equal to 2 to the power of 1 plus 1 minus 1 over 2 minus 1 times the quantity of 3 to the power of 1 plus 1 minus 1 over 3 minus 1 times the quantity of 5 to the power of 1 plus 1 minus 1 over 5 minus 1. Then, simplify. Sigma of 30 is equal to the quantity of 4 minus 1 over 1 times the quantity of 9 minus 1 over 2 times 25 minus 1 over 4 is equal to 3 times 4 times 6 equals 72. So, the sum of the divisors of 30 is 72.
Let's recap what we've learned today. First is the number of divisors formula, which is d of n equals the quantity of e to the power of 1 plus 1 multiplied to the quantity of e squared plus 1 and so on and so forth. Second is the sum of divisors formula, which is sigma of n equals the product from I equals to 1 to k of the fraction p sub I raised to the power of e sub I plus 1 minus 1 all over p sub minus 1. Third and last is we solve examples to practice both concepts. Remember these formulas as they're very useful in number theory. Thank you for joining us in this lesson on divisors. We hope you found it insightful and enjoyable. Don't forget to try these formulas on other numbers to deepen your understanding. See you in our next lesson.